Okay, so today we're going to talk about solving systems of linear equations. Linear equations are from Algebra 1, the equation of a line. And if you have two linear equations, they can share solutions. Sharpener will be up top there, okay? So if you have two lines, they could share a solution where they cross. A line represents a set of all points that are solutions. So if you have just one line, for example, any point on that line is a solution, and there are an infinite number of points on that line. But if you have two lines, you want a solution that works for both equations, and that only happens where the lines intersect. Sometimes you have two equations and they actually describe the same exact line. And if in that case, all of the points on the line are solutions, so there's infinitely many solutions. And sometimes you get parallel lines. Parallel lines will never cross. They have to be perfectly parallel to have no solution. If they're almost parallel, it might take them like 50 years until they cross, but they will cross eventually. So if they're not perfectly parallel, then they'll have a solution somewhere. If they're parallel, there's no solution to that system because they will never cross. So the first method is to solve by graphing. So in Desmos, you can graph these two equations and find where they cross. So I'm going to do that, but I also want you guys to do that. So open up your Desmos and we're going to graph those two equations. All right. So when we see the lines, I can see my red line and my blue line. Every point on my red line is a solution to the first equation. Every point on the blue line is a solution to the second equation, but they have one point in common, and that point is a solution to both equations. Is that what you guys have there? Y equals 2x, 3x minus y equals 13. Not that one. It's that one. So this point right here, see, it shows up as a point because it's an intercept, but that's not what I'm looking for. I'm looking for the point where the two equations cross right there at 4.4, comma 0.2. Are you guys getting the same? Yeah. Okay. All right, so on your paper, you're going to write that as your solution. The solution has an x value and a y value, 4.4, comma 0.2. Now that seems pretty easy, right? You type it in Desmos, you find the point that they have in common. So you can always check a solution this way. On your test for this unit, you'll be able to do that. We're going to do an exit ticket today, though, where we are not going to have Desmos because I want to be able to follow your thinking pattern for substitution or elimination, these other two methods, and you'll get to pick. So let's go back to that. So this is decent for checking your solution, but you will need to know how to solve algebraically as well. So substitution, the first step is to choose an equation and solve for one variable. It means get a variable by itself. Looking at the first equation and the second equation, which variable will be the easiest one to get by itself? The second equation, and do I want to get the x or the y alone? You could do the y because some people are used to it, but I think the x might be easier. There's actually plenty of ways to do this problem. You could get this x by itself, this y by itself, this x, this y. The reason I like this x is because there's no coefficient there, so it's just going to save me that step. So that's what I'm going to do, but if you would like to try it differently, you can go ahead and do that. So to get the x by itself, I'm going to undo plus 2y with a minus 2y. And I get x equals 2 minus 2y. Okay, step 2 says substitute the expression for the first variable in the other equation and solve for the second variable. So what this means is this. I'm going to try to see if I have a highlighter. I think I do. X is exactly the same value as 2 minus 2y. So in my first equation, I can replace the x with 2 minus 2y. So here, I can take this 2 minus 2y and I can put it here for my x because they are exactly the same. That's what I just wrote, that x is exactly the same as 2 minus 2y. So I'm going to take my first equation here and I'm going to write 3, and then instead of the x, I'm going to put in the 2 minus the 2y. And then I continue writing plus 4y equals negative 4. Okay. I'm just going to pause for a minute and make sure everybody got that step, because I feel like that's very essential. Once you have that step, we're just doing a little bit of... All right, so I am going to distribute. I get 6 minus 6y plus 4y equals negative 4. I'll combine like terms next. So I have 6 and a negative 2y equals negative 4, and subtract the 6. I'm getting negative 2y equals negative 10. And up here, I'll continue that. Divided by negative 2. And y equals 5. Now, it's really easy to make a small error when you're solving these, because you'll get an answer regardless. Did you guys get the same as me, or did I make any errors? You got the same? Good. All right, so look at my answer so far. I have y equals 5. Does that look like the answer I got from the first one? What do you think I need to find? Yeah, I have to find the x. To find the x, I can put it back in this equation, or this equation, or this one. And this one's going to be the easiest because the x is already by itself. So I'm going to use that one. I'm going to use x equals 2 minus 2y. And I'm going to substitute in the 5. Be careful about your order of operations here. You can put 2 minus 2 times 5 in Desmos, but it's important to also know that when you do this, you have to multiply first and then subtract. So I'm going to have 2 minus 10, which is negative 8. Okay, and then I have a point. X comes first, and then y. All right, so another way you can solve is called elimination. And I'm going to let you choose always if you solve with substitution or elimination. That's up to you. Some people always like to do the other one. Personally, I think that sometimes it's easier to do substitution and sometimes it's easier to do elimination, and I just do whichever is easier in that situation. So in elimination, basically you are adding the two equations together or subtracting them from each other so that you can eliminate a variable, eliminate the x's or eliminate the y's. They're not gone forever. They're just gone temporarily so that you can solve the problem, and then you can go back and find your x and your y. So in order to do that, if I added these together, nothing would cancel. And if I subtracted them, nothing would cancel. So you have to first multiply each term by a constant to get coefficients that are opposites. So like right here, I have a negative 2y and a positive 1y. I could multiply this whole equation by 2. And if I do that, then I'm going to get a 2y that's going to cancel out with this negative 2y.
How do you get the 2 to multiply?
So the reason I'm allowed to multiply by the 2 is because I do it on both sides. So think of an equation as a balance, right? I multiply the one side by 2, and it's okay if I multiply the other side by 2 because it's still balanced.
I mean, like, how did you get the 2?
How did I know it was 2? So I was looking for opposites. You don't always have opposites, so sometimes you have to multiply by a negative number. But I was thinking, what could I multiply this y by so that I can get the opposite of negative 2y? And so then 2 times 2x is 4x. 2 times y is 2y. And 2 times 1 is 2. And I'm going to combine that with the second equation. Sometimes people don't rewrite the second equation, and that's okay. I'm just kind of showing what I'm doing. So what I'm doing is I'm adding these equations together because I have 2y and I have negative 2y. And that's going to cancel out. 4x plus 4x does not cancel out. It's going to give me 8x. These cancel. And I get 8x equals negative 8. Uh-huh.
Is it always going to be more positive or always something negative? Like
So
plus or
sometimes
minus?
people like to subtract the equations. I find it a little bit tricky to subtract the equations. So I usually try to add. So yes, I usually try to have one positive and one negative. But you could subtract the equations. It's allowed. All right, and then I'm going to divide by 8. And I get x equals -1. And then I get to substitute back in. This time nothing is solved for x, so that there's not one that's going to be easier than the other. The first one looks a little simpler, so I think I'll use that one. But you could use either. Put the -1 in. And solve for the y.